Okay, here's a quick explanation of the practice problems I suggested that you do for 11.4. We'll start with letter C. What I see here is a CH3 and a CH2, so I'll condense that. There we are. Next I see an oxygen and then a CH2 and another CH2. So I'm going to combine the two CH2s in parentheses and put a 2 beside it. The last thing we have to add is this OH group, so that just goes on the end. Now we'll take a look at letter D. I see a CH3 group, then a CH2 group, so I'll condense that first. Next, I see this carbon, and it's surrounded by 1, 2, 3 CH3 groups. So I'll draw the carbon and then put the 3 CH3 groups in parentheses with a 3 beside it. And there we have it. Okay, this is problem 11.8, letter C, and we're going to draw a structural formula for this. So the first thing I see is this CH3. I'll draw that out. Next, I see a carbon with 3 chlorines on it. Now, the chlorines are halogens. They bond only once, kind of like hydrogen does, so they're each going to be a dead end. So they should individually be bonded to the carbon. To give each one of these chlorines a full octet, we'll put 3 lone pairs of electrons around each one. Okay, that should do it. That's the structural formula for that compound. Now we'll take a look at letter E. I've got CH3s here, but more than one of them, so I'll draw this carbon I'm pointing to first, and put the 2 CH3s coming off of it. Now, as we know, this carbon needs 4 bonds, and it currently only has 2. So a 3rd bond will be to this hydrogen, and the 4th bond will be to this carbon. Okay, so this carbon, which I just drew here, needs 2 hydrogens coming off of it. Next, we see the nitrogen with 2 hydrogens coming off of that. That nitrogen has 5 valence electrons, so it will make 3 bonds, which we have, but it's going to need a lone pair to get its full octet. And there we have the correct structural formula for this condensed formula. This is problem 11.9, letter C. Do you see this hexagon of 6 carbons right here? So I'll draw those out first. I'm going to draw a structural formula for this. So again, don't overcomplicate it. If you see a hexagon, draw a hexagon. Coming off of this carbon here, I have a CH3, so I'll draw a CH3 coming off here. Next, I'll draw this OH group coming off of this carbon. Lastly, I have a carbon with 2 CH3 groups coming off of it, so I'll draw that next right here. The last thing I need to do is revisit every one of these carbons and make sure it has 4 bonds, and if it doesn't, I'll add hydrogens until it does. Hydrogens are usually drawn outside of the circle instead of inside, and just be sure you've added this hydrogen specifically and this one, because they're often missed. Feel free to try the rest of the practice problems for this section 11.4. I put the answer key linked below.